Hello, good morning. This is a demo on our one of the experiment, that is synchronous 4-bit up counter. So we know that for a 4-bit up counter, it will count from 0 to maximum value, that is 4 bit, its maximum value is 15. So it will start counting from 0, 0, 0, that is from the binary value, and it will end up with the value 1, 1, 1, because it is 0 to 15. So up counter 4-bit. Okay, so when I say it is a synchronous up counter, we need to, for an experiment, we need to see what all components are required. Okay, here we are using one 7476 IC. So please note that it's a negative edge triggered flip flop, negative edge triggered flip flop. Okay, it is 7476, which is a negative edge triggered flip flop. And as per the design, we need one more IC, that is 7408, that is an AND gate. Okay, so we are connecting here two 7476. First one is a 7476, and adjacent to that is again a 7476, and other IC that is being connected is 7408. So here, why are we connecting two 7476? Okay, so in a single, if you look at the data sheet, you can see in a single 7476 there are two flip flops. Okay, so we are connecting two 7476, so it means we are having four flip flops together. Okay, all together four flip flops. Why we require four flip flops? For a single flip flop, we can store only, for a one flip flop can store only a single bit, at least that is only a 1 and 0, because it is digital value, binary values. And since we want to connect four values, four flip flops for a 4-bit storage, for this counting from 0, 0, 0 to 1, 1, 1, we require 4-bit storage. So we are using four flip flops. So one single 7476 have two flip flops, another flip flops, another such a flip flop will have another two flip flops. So all together we have four flip flops. So that is about the component details. Okay, now we have to look over, after all doing all the connections, what we have to see is we have to look over two important pins for a flip flop, that is the preset and clear. Okay, so preset and clear are known as asynchronous inputs. Why do we say they are asynchronous inputs? Because they are not dependent upon the clock signal. Okay, so now I have done a connection. Now I am not, okay, this is our clock pulse. It is a monopulsar, that is our clock pulse. We are giving, after on clicking one pulse, we will get an output. Okay, so now I am not clicking over the clock pulse now. Now without having the effect of clock pulse, you can see my first pin that is connected is preset here. So when it is preset, you can see all the outputs will go high. Okay, so in order to show you, I am just clearing all the signal, and after clearing the signal, if I put the preset pin down, okay, it is now down here because it is active low here. That is why for a low signal only the preset will be active. Now what is actually preset? Without the effect of any other signal, when the output will go high. Okay, that is preset, it will preset all the outputs. So that is why it is setting all the outputs. Okay, now the preset is working here. Now after that you have to put the preset back to high position. Okay, now you have to see whether it is clear signal is working. Clear means without the effect of any other signal, the output will go 0. So here also we have a active low clear signal. So I am putting the second pin, that is our clear signal, to low. So when I put this low, all the outputs, that is the 4 output pins or 4 LEDs that is being connected, it has gone 0. Okay. Now if you want to check whether our experiment is counting from 0 to 15, we have to put the preset and clear both in the high state. Okay, both in the high states. Now so at present my clear is in the low state. Now I am going to put in the high state. Okay, so remember, now our preset and clear both are in the high state. Now if I give a pulse here or a clock pulse here, you can see now the initial state is 0. The first output will come here. After giving a mono pulse, it will give 1. 1 is, here is your LSB. So this is your LSB. Then you have the value as 0, 0, 1. Okay. Now when I give the next clock pulse, I will get 0, 0, 0, 1, 0, 0, 0, 1, 0. Next is 0, 0, 1, 1. Next is 0, 1, 0, 0. Then 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. This is 9. Then is 10, 11, 12, 13, 14 and 15. After that, if I give a pulse, it will go back to my initial state, that is 0. So this is our 4-bit synchronous up counter. Okay, in this way you can design 4-bit down counter also, 4-bit down counter. Okay, and you have to remember every time when you do the connections, you have to do whether you have to check the preset and clear properly for each of the looking over the IC data sheet, and you have to put both the signals to the high mode. If they are active low, you have to put them in the high state when you are doing the experiment. So that is all about synchronous 4-bit up counter.